Page replacement algorithms in operating system.
Yes,
Okay.
sir.
Yeah, fine. Let us start with the session. Okay. Just I'm using this particular thing for the problem. Okay. Yes. Previous session, we just discussed with the mm, page replacement algorithms like the demand paging and what is its importance. So what happens if the page fault occurs? Okay, so lazy swappers, those things, and we come across with two important things. One is the page replacement, another one is the frame allocation. So with that, what we did is like say for example, in the previous session I discussed about the first in first out. Okay, the first in first out replacement algorithm. Like what we did is we have considered uh, three frames, and this is what the string reference. Oh, okay, this is the reference string that we have used just like it is a page number. So what we did is we just used three frames, and how exactly the first in first out a page replacement algorithm is going to work, and how exactly the page, whenever the page is not there in the page table, how which page has to be replaced. So that is taken care by the that is done by using the FIFO algorithm. So that is what I think. So yesterday, the previous session we discussed. So we calculated the page fault, we calculated the page hit, everything we calculated. But there is one problem in this. So what is that problem here is like say, can you just tell what exactly what will be the problem in this? Anyone can say that, okay, like say what exactly the problem will be in this case? Anyone? Anybody? Anyone can just say that what will be the problem in the first in first out algorithm, first in first out replacement algorithm? Anyone can
Hit
say
ratio is very less.
what? Page
Hit
hit ratio is
ratio.
okay. So can you like say, can we assume that if the number of frames, okay, if the number of as of now what we have done is we have considered only three frames, and we have the reference string, and we try to insert the page as and when required, and whenever the page fault occurs, we what we did is we just replaced the page based on the first in first out algorithm. But can, like if I say that if the number of frames when we increase the number of frames from 3 to 4 is can the page fault ratio is can be reduced or not? Anyone? Is it can we reduce the page fault ratio, or if the page hit ratio increases if you increase the number of frames? Anyone? Is it possible? What happens if I increase the number of frames in case of first in first out? Anyone? I have so many people here. We have 18 students. Okay. So anyone can answer this question. If I increase the number of frames from 3 to 4 in first out page replacement algorithm, is the page hit ratio is increased or not? Anybody? Anybody can answer this question. Increases
No,
or not?
sir.
No. So why? So what is that called? Why it is not increasing? So okay, fine. Let me come to this particular thing. That is the this. Okay, I think so. Now we are seeing some this one. Let me take with first in first out. Okay, so now what I will do is I'm going to say, for example, just a minute. I just admit. Okay, so I'll just take this example, and we'll just consider that four replacement algorithm, four frames. Okay, so earlier we had considered only three frames, and now we will consider four frames. So let me take this. Okay, so I have four frames here. So initially what happens, so anybody can answer together along with me. So I have 1, 2, 3, 4 frames. Initially it is empty. So now whenever the CPU request for the page number 7, is that page number 7 is there in the uh, this one in the memory or not, in the page table or not? Can I just get the page number 7
No,
from this? No. So what is this
no.
called as? Page fault. Okay. So what I'll do is I'll indicate this as page fault F, and now I'll try to insert the page number 7. Okay, the page number 7 in this. Now, next one is, say for example, if the FIFO, okay, that is the this one, a request for the next page. So the next page is what page number is 0. So the 0 is also not there in the this one. So I have only page number 7. So now what I will do is I say that this is the page fault. So what I will do is I'll say that 0 here. So now 7 and 0 are there. Now similarly, whenever the this one request for the next page, that is say for example page 2, so I'll just write 4 frames. So now again there are 2 is not there in the page table, so it is a page fault. So now what I will do is I'll bring this particular 701. So now 1 is located inside the frame, page number, frame. So now again, if I go for the next this one, so what I will do is the next reference string I am just referring is 2. Now whether the 2 is there in the page table, no. So now again it is a page fault. So again I'll say that it is a page fault F. So now I'll just bring that particular page number into the 7012. Okay. So now all the frames are loaded. So none of the frames are free in the memory. So now what we have to do is the next this one, that is which is the next frame it is requesting for. The next frame it is requesting for is the page number it is requesting for 0, but 0 is already there in the memory. So what I will do is I'll just write as it is. I'm not going to do any changes for this. I'll say 7012 and I'll say that it is page hit, because already the frame is stored in the already the page number is stored in the frame. The next one is, the next thing I have to consider here is 3. So whether the page number 3 is there in the frame, no. So whenever that particular page is not there in the frame, then what we have to do, we have to use the first in first out page replacement algorithm. So which was the first page number that was loaded into the memory, that was 7. So now what we have to do is we have to replace the 7 with a new page number, that is 3. So now what happens here is, now our memory, that is the page table looks like. So the 7 is replaced with 3. So I'll write 3012. So now again, even though it is not there, so I'll just say it is page fault only, because it was not there. So the next what we are doing is, next reference string we are checking is for the 0. So whether that particular page number 0 is located in the page table, yes, it is there. So it is a page hit. So what I'll do is I'll just copy as it is. I'm not going to do any changes for it. So I'll just say 3012 and I'll say it is page hit. Okay, so page hit it is. So next one is, the next reference thing we are looking for is 4. Now whether the the page number 4 is there in the page table, no, it is not there. So now we have to apply the FIFO page replacement. So whenever we apply, which was the next page that was brought into the main memory, that is 0. So this is the second location. So I want to replace 0 with the 4. So now what I'll do, I'll just erase this particular this one, that is 0, and I'll replace it by the new page number, that is 4. So instead of 0, I'll replace with 4. Okay, so now I'll get 2, and since that particular page was not there, so I'll just consider that as I'll consider it as the page fault. So page fault. Okay. So next, if I just check with the next one, so it is which reference thing? It is 2. So 2 is already there. So I'll just copy as it is and mark it as page hit. So now what I'll do, I'll just say, I'll write the frame. So it is 2. So 2 is already present in our page table. So it is a hit. I'll just make it as hit initially, and just I'll write whatever the previous thing is there. I'll just write it as it is. So 3412. Now, if I take the next one, that is which is the next reference thing, 3. So is the 3 is already there? Yes, the 3 is already located in the this one, that is the page table. So what I will do is, so I'll say 3412 as it is and mark it as I'll just mark it as that is page hit, because the page whatever the CPU is looking for, it is already stored in the page table. So 3 is already there. The next one is it is looking for 0. So whether the reference string 0, page number 0 is stored in the page table, no. So now what we have to do is we have to replace. Okay, we have to find one page as a victim frame inside the page table and replace that with a 0. So now which one I have to replace? Which yeah. So I have to replace with the that is the page number 1. So now the new thing is 3 4. So 3 4. Now it will take 0 here, and the last location is 2, and I'll say this is also page fault. Okay, so similarly if you go for the next one, so next one is 3. So if you just look at the reference string 3, now you can just see that 3 is already present in the page table, so it is a page hit. So what I can do is I can just write as it is. Okay, so I'll just like 3 4 0 2, and I'll make it as page hit. Okay, so similarly if I go to the next one, that is what is the next reference string, that is 2. So 2 is already stored in the page table, so it is also a page hit. So now what I can say is I can just write like this. Okay, I can just copy the retain whatever the page numbers are there in the page table, and I can just say it is also page hit, because already that particular string 2 is already stored in the page table. Okay, the next one we are referencing is the page number 1. So if you look at into the page table, 1 is not there. So now I need to replace that 1 with a existing page number. So we have to so 2 will be, so we have to replace that is the last frame is, that is 2. Okay, so I'll just 3, the first row, the first 3 page numbers will be as it is. The last one will be replaced with a new page number, that is 1, and I'll mark it as page fault because it was not there earlier. So next one, if you just check, so it is the reference string, it is 2, but 2 is not there. So again we have to replace that. So whenever I replace this, so what is this replace? If you take that, so the first one, now already one turn has been done. So first in, first out. So which was the page number that was inserted into the page table first? It was 3. Now you replace that 3 with the a new page number, that is 2. Now 2 4 0 1 is what the thing. So this is what the page fault. Sorry, this is also page fault. Okay, so I'll just a minute. So this is also, it is page fault. Okay, yeah. So this is 1. Okay, this is page fault. Now the next one is 0. So let us check for 0. 0 is already present in the page table, so then it will contribute for the page hit, since the page number is already existing in the thing. So I'll just say 2 4 0 1, and I will mark it as page hit. Okay, H. So next thing we are looking for 1. So 1 is already stored, so now I'll just go with this. Okay, so 2 4 0 1. Okay, now I'll just say it is also page hit. So next thing you are looking it for 7. So now whether 7 is stored in the page table, no, so it is a page fault. Now which page has to be replaced inside the page table? That is with the page number 4. Yes, so now just I'll take one more page. So 2, the first page number will be same. Now 4 is replaced with 7, and now the remaining 2 location as it is. So now I'll just say it is page fault. So next one is, the next string we are taking it is 0. So 0 is already present, so no need to worry. So I'll just say I'll just take it as 2 7 0 1, and I'll say hit. Okay, so next one is 1. So 1 is already stored. I'll retain, I think so I'm not able to write this. So if I write 2 7 0 1, and I will mark it as hit. Okay, so hit. Now you calculate how many page faults are there. So 1 2 3 4 5 6 7. Okay, 8 9 10. So how many page faults occur? 10. But so in the this one, how many was there in the previous thing? Like if you take this particular thing, okay, like say for example, if I go with the 3 frames, it was the page fault, number of page fault was 9. Okay, now if you go with the 4 see here, before in the last slide I took. Okay, so how many page faults were there? So 1 2 3 4 5 6 7 8 9 10. Okay, 11 12 13 14 15. Okay, I think so 15. I took the same thing. Okay, so but for some page, the page fault may increase as the number of allocated frame increase. This is called as FIFO. So what happens here is, like say for example, if you go for the instead of 3 number of frames, yeah, Just a minute. 7 is not there. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 page faults. Okay. But in this case, yeah, just a minute. In this case, we are having, in this case, we are having around how many page fault? 1, 2, 3. Okay. 4. Okay.
10,
4.
10.
10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and
20
again it is 20. 10 by 20 is how much? It is around
50%.
50%. 50%. So 50% is the hit ratio and 50% is the page fault ratio. Okay. Just a minute. I think so. Somewhere I have gone wrong with this. Whenever I increase this particular page fault, okay. Uh, but it just a minute. And just a minute. If I go with this thing, okay. If I go with this, yeah. So 7012, okay. So I have page fault because first three. So we have because the page 7 was bought, okay. So if you just look at the number of page faults, whenever it goes with the one frame, two, it is around 12. So before it may face the problem. So for some page replacement alone, the page fault may increase as the number of allocated frames increases. This is called as Belady channel. Okay. Uh, okay. So because it is a page fault here, it is increasing. I don't guess so. So first in, first out, 70. I think so. The same thing I have taken here also. Okay. Just a minute. I'll just look at with this one. Uh, uh, okay. Uh, just a minute. If I just take this, okay, same I think so. There's no any change in this, but when you take this, the page fault should increase. Okay, 7. If I take this 701, okay, uh, uh, yeah. So uh, 701 I got. Then there is 7012. Okay, then 0 is there, it is hit. Then 3 it is a page fault. Then again it is 0, it is a page hit. Okay, so 4 again what happens here is it is a page fault. Then 2, I think so I had gone wrong here somewhere. 3, 4, 1, 2, it is a hit. Okay, it is there already, it is there. So after 2, then again it is 3, it is hit. Then again it is 2, which is a page fault. So we are replacing. So the thing here is, like say for example, the what I was able to say is, like say as you can just check in this particular diagram. The one thing here seen here is, in this particular graph, we can notice that as the number of frames, okay, as the number of frames increases, okay, the page fault also increases. Like say if you come this with 4 frames, okay, as we have got that the page fault is 10. Okay, similarly here also I am getting the page fault as 10 itself. Okay, the number of page faults that has been occurred with our whatever the workspace we have, whatever the in this particular thing. So there are I have considered with the four number of 4 frames. Okay, earlier we took the same reference thing and we executed for 3 frames. So in 3 frames we got page fault as 15. But when we go with a page fault, like say for example, when we come across with the 4 frames, it is giving us a 10 page fault. Means in some cases, it's not going to say that in all the cases, but in some cases, what he says that is whenever you increase the number of frames, okay, so the page fault also increases. Instead of reducing the number of frames, it says that it depends upon the reference string what we are going to consider. So it says that, like say for some page replacement algorithm, the page fault may increase as the number of allocated frames increases. So this is what we call it as Belady's anomaly. So the first in first out algorithm also it is going to suffer from this. I don't think so here. Here whatever he has given, I think so for 3 saying that the page fault is 9. Okay, page fault is 9, and for 4 it is saying that the page fault is 10. So but if you go here 7012, if I take this particular string here, So I have this like 1, 2, 3, 4 already 4 page faults. Okay, so now if you take 3, you have to get this. So usually I think so something that this one he has the next reference 3 replaces with 0, and this one, so page 1 is then replaced by 0. So this is what, like, say, I think so there is some this one. Okay, I'll just rectify this afterwards. So this is what thing I was able to tell you, like, say, for example, Belladis anomaly. So what exactly the Belladis anomaly means here is, like, whenever we take, okay, usually whenever we come across with the string, okay, if you take the same string and if you come across with the number of frames, if you increase, definitely it is going to increase the number of page fault. Like, say, let me take this one. Okay, let me take a different string. Let me take a different string, because otherwise it will, for us it will be that whatever the concept is there, it will not be clear for us. Okay, let me take the this one. Okay, another one new reference string I'll take. Let me test for this. Okay, let us check for this, and anyone should tell me the answer for this. Okay, parallelly I'll just write this reference string. Okay, so let us take the reference string. Small reference string will take the reference string is uh, 1, 2, 3, 4. Okay, 4, 1, 2, 3, 4, 1, 2, 5, 1, 2, 5, and 1, 2, 3, 4, and 5. Okay, 1, 2, 3, 4, 5. So this is what our reference string. Okay, one. So how many reference strings we have taken? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So only 12 reference strings I have taken in order to this one. Okay, so let me have this. I'll just instead of taking one box, I'll just write this. Okay, so normal FIFO. If I take normal FIFO, okay, just a minute. I'll take this one. Okay, yeah, I'll write this. Okay, fine. Okay, so I'll just write some this one. Okay, okay, yeah. So let me take initially 3 frames. I am taking 3 frames. Okay, so now parallelly anyone can say please unmute yourself and just tell me. Okay, normal in case of FIFO, I'm just saying that in FIFO, because if I want to demonstrate the Belladis anomaly, let us take this string and check what happens exactly with the number of how the page fault increases. So if I take this, like initially, say for example, initially the all the page number, the page table is empty. So whenever the CPU requests for the page number 1, so now what happens? So initially the one, nothing is stored, it is empty. So the first one, it says that 1, and it is the page fault. Okay, I'll say it is a page fault. Okay, so the next thing it is requesting, it is 2. Okay, I'll say 2 here. It is also a page fault. Next one, it is 3. So 1, 2, 3. So it is also a page fault. Now 4 will come. So which one I have to replace?
1.
Which one I have to replace? So I have to replace that with the page number 1. So now it is 4, 2, 3. Okay, 4, 2, 3. Now the next one is so this is also a page fault. So next one is 2. So I'll just write as it is. That is 4, 2, 3. Because no, sorry. 1 I have to take. So just a minute. So I'll just take here. I'll just take it is the next one. I'll just mark here. Okay, I'll just mark so that I'll be able to follow the thing. So for 1, so 1 has to be replaced with which one? That is 2. So 4, 1, 3. Again, it is a page fault. Now what is the next thing? That is 2. So whether 2 is there? No. So 4, 1, 2. So it is also a page fault. Next one is 5. So 5 has to be replaced with which one? So first one, that is 4. So it is 5, 1, 2. So it is again, it is a page fault. So now it is 1. So it is already present. That particular page number is already present. So I'll say 5, 1, 2, and I say that it is a page hit. 2, yes, 5, it is already present. So 5, 1, 2, it is page hit. 3 is not there. So which page I have to replace? So which page I have to replace? So which page we should replace? Okay, it is we need to replace with the 1. So it will become 5, 3, 2. So now what happens? So it is page fault because 3 was not there. Now the next one, the next frame it is requesting is for 4. Now which page I have to replace? So I have to replace it with the page number 2. So 534. Okay, 534. The next one. So the next one is 5. So this is also fault. So next is already there. So I'll say that 534. So now if I want to have page fault. So how many page fault are there? How many page fault if you look? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm getting that 9 page fault, and page hits is number of hits is. So if I take this 1, 2, how many hits? That is last one is also hit. Sorry, here 5, 3 or 5 is already present. So number of page hits is 3. So number of page fault is 9 and number of page hit is 3. Now let us take the same string and substitute it for number of frames is equal to 4. Okay, so let us understand why he is saying that if the number of frames increases. Say in the previous example, make sure that the number of page fault was 9. Okay, now let us increase. Okay, let me increase this, the number of this one. Okay, let me take this particular thing. Okay, so I'll have this one. Okay, so sorry. Okay. Okay. So 1, 2, and 3 and 4. So I'll have 1, 2, 3, 4. Okay. So let us take the first thing, that is 1. So it is page fault. 1, 2, it is page fault. 1, 2, 3, it is page fault. 1, 2, 3, 4, again it is a page fault. Okay, so now again, if you just come, anyone, just unmute anyone. Okay, please please be in parallel with me. So 1, 2, 3, 4. Okay, so now the next one, the next reference string is 2. The next reference string is 2 is already present in the page table, so it is a page head. So I'll just say 1, 2, 3, 4 and mark it as page head. Okay, so if I take another one string, like say 5, so if you take this particular 5, so 5 is not there, so I have to replace that 5 with the existing page number. So I think so 1 is the first page that was inserted into the page table, so replace that 1 with 5. So 5, 2, 3, 4, and now make it as page fault. The next one, so which is the next one, that is 1. So 1 is already 1 is not there in the page table, so you have to replace. Now you replace that with 2. So 5, 1, 3, 4, and you make it as page fault. Now if you take 2, so 2 is also not there, so just replace that with 5, 1 with the page number 3. So 2 and 4 and make it as page fault. Now the next thing is 3. So 3 is not there, so what we have to do is we have to replace. So 5, 1, 2, 3, it will become and make it as page fault. Now the next thing it is requesting is for 4. So now what we have to do is 4. So where is 4? 4 is not there, so replace it with page number 5. So I'll get 4, 1, 2, 3, and it is also page fault. Okay, so now how many hits was there? Okay, page fault, hit. So somewhere have we gone wrong? No. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. The last one is 5. So which one I have to replace? So after replacing this, so the last one, the last frame is 5. So where we have to replace? So 4, 5, 2, 3. So again it is a page fault. Now if you look at this particular thing, okay, so I think so one thing where I have gone wrong is, I think so I have left one. One is there. 1, 2, 3, 4. The first of 4 is clear. Then we come across with 1. So 1 is already. No, 1, 2, 3, 4. I have skipped with 1. So this one, Narayan. This
no, sir.
one,
next one.
Not...
Okay.
No, next one,
yeah.
This one.
Anything. Okay.
It is 1. So I'll just write here 1, 2, 3, 4, and it is make as hit. Now, how many page faults are there here? Page fault. If you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So page fault here is how much? Page fault is equal to 10. Page hit is equal to 3, so, 2. So no, so whenever I increase the number of frames, usually what we have to get, whenever I increase the number of frames, the page fault ratio should be reduced. But if I increase the number of frames in this particular case, the number of page faults is increasing by 1. Earlier I had page fault is equal to 9, but now I had page fault is equal to 10. So this is what we call it as Belady's anomaly. So first in, first out page replacement algorithm is going to suffer by Belady's anomaly for some reference string. So we need, so what we are going to do is we are not going to use this particular replacement algorithm in case of this one. So now let us go to the next type of this one, that is like say the next one is so that is what he has told. So you can just refer to the graph. Whenever the frames was 3, the page fault was 9, and when I increase the number of frames, it was 10. So that is what we call it as Belady's anomaly. So it is one of the very, very important question from the point of examination. Okay. So next thing, the next algorithm we call it as optimal page replacement algorithm. So what is this optimal page replacement algorithm? So whenever we consider this optimal page replacement algorithm, see, is used to solve. So in order to overcome from the disadvantage of Belady's anomaly, we go for optimal page replacement algorithm. So what it does is it has the lowest page fault rate of all the algorithm. But what we can do is, what happens in this case is it is going to replace the page that will not be used for the longest period of time. Means we are going to check which page is not going to be used for the longest period of time. With that, we are going to replace that particular frame. So like say for example, the longest frame is like we are going to check. So let me come to the, again we'll just go to the work example. I'll just write down the string, that is 7012030423 0 0 2303212017 01. So now let me come to this. Let us work out with this particular optimal replacement algorithm. So so make sure that, see which one we have to replace. Please understand this particular line, that is replace the page that will not be used for the longest period of time. So whichever the page that is not used for the longest period of time, that we have to replace. So let me take this to the, again let us come to the workspace. Okay. Yeah, so I'll just write the reference string. So let me have this particular reference string, like say the same old reference string will write 70, okay, 7012037012030404, okay, 0423023032, okay. Now 1120171701. Okay, so I'll repeat 70120330321201. Okay, this is what. So let us consider the, again we'll just go with the 3 frames itself. So I'll just write 3 frames. Okay, I'll just write 3 frames. Okay, instead of writing separately, instead of wasting the space, I'm just writing together. So I'll have 3 frames. Okay, at the columns. Okay, so let me write the columns. So let us take one. So the first one, the first page number we are looking is for 7. So 7 is not there. So I'll just say it is page fault. 0, it is also not there. So 70, page fault. Okay, next one, 1. So 1 is also not there in the page table. I'll make it as frame. Now tell me, anyone, the next thing we are looking, or the CPU is looking, is for page number 2. Now page number 2 is not there. Page number 2 is not there in the page table. Now which one or which page has to be replaced with the new page number 2? Which one?
7. 7.
Very good. Because it is the longest page. See, look at here, which is the longest one. So if you just look at here in this, like you have to look at whatever the page numbers that is already stored in the page table. Look in that particular thing. So if you just check 7, after after 2, 7 is not there. So after, see, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So after the 14th, after 13th iteration, 7 is recurring again. If you take 0, immediately after 2, 0 is coming. If you take 1, so after before 7, 1 is occurring. So I cannot replace with 0 and 1. So we have to replace with only 2. Now what I will do is I'll just replace 7, page number 7 with 2 and make it as 201, and I'll call this as page fault. Okay. So next one, if you just check what is the next reference string, it is 0. So 0 is already there. So no need to do anything. 0, 1, this one, and I'll mark it as page hit. So the next reference string I'm looking for 3. Now, if I want to look for 3, now which one I have to replace? So which frame we have to replace? Which one? Which one? Just check. So 2, 0, see 1, 2 is there, 0 is here, okay, and 1 is somewhere else. So now you have to consider 1. So 2, 0, 3 and make it as page fault, because if you just check in this particular previous field, see here, I have to replace some of this one. So 2 is occurring after second iteration. After 2 iteration, 2 is coming. 0 immediately after 1 iteration. So 3 is coming after 3 iterations. So which one is the longest page? That is 3. So I'll 1. Sorry, 1. So I'll just replace 1 with the page number 3. Now, if you just check 0, so 0 is already present. So what I'll do is 0. So I'll just say 203 and mark it as page hit. Okay. Similarly, if you come to the 4, so now I'm at the reference string 4. Now, if I want to replace, because 4 is not there, so it is a page fault. I'll mark it as page fault, and I'll say I have to check which page is which is the longest period page that will occur in the longest period of time. So 2 immediately after 4. So 0, it is here. 3 is so 0. So I have to replace that with the 0. So now what I'll do is so 2, 4, okay, 2, 4 and 3, and I've already marked it as page fault. Now I'll take 2. So 2 is already there. So I'll say 2, 4, 3 and mark it as page hit. Okay. So next one, the next reference string I'm considering is 3. So 3 is already there. 2, 4, 3 and mark it as page hit. So next one is 0. So 0 is not there. So which one I have to look? So out of this, which is the longest one? So 2 is occurring here and 3 is occurring here, but 4 is not occurring itself. So what I will do is I'll replace that with the page number 4. So 0, so 2, 0, 3. So I'll replace it and I'll make it as page fault. So next one, if you take 3, 3 is already there. Okay, so 2, 0, 0, 3 and mark it as page hit. So next one is, if I take 2, 2 is already there. So 2, 0, 3 and mark it as page hit. Okay. So next one is 1. So 1, the next referencing is 1. So if you look at the page number that is already stored, 2 is there. 2 is immediately occurring after 1. So I cannot replace it. 0 after 2 and 3 it is not occurring. So what I'll do is I'll just 2, 0. I'll replace page number 3 with 1 and mark it as page fault. Now next one. So next one is 2. 2 is already there. So 2, 0, 1 I'll take. Next one is 0. So 0 is already there. So 2, 0, 1 I'll take and mark it as hit. So this is also hit. So hit. So again, if you take 1, 1 is already there. 2, 0, 1. Okay. So hit again. It is an hit. So now what happens in this case? So that is the next one is 7. So if you look at here, 0 and 1 are occurring. 2 is not there. So what I will do is I'll replace it with 2, 7, 0, 1 and mark it as page fault. Next is 0. So 0 is already there. So 701 I'll take and I'll mark it as hit. And again, 1 is the last string that we need to refer. So it is already present. So 701 and I'll mark it as hit. So if I take fault, page fault is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 page fault. And for hit is equal to, if you just see the hit, so it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hits. So now, is it not our page hit ratio is increased compared to the first in first out algorithm? Yes or no?
Yes, sir.
Yes. Why? Because if you take here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If you
20.
divide 9 by 20 is how much? What is the page fault ratio? 9 by 20.
45%.
45%. Hit ratio is
45%.
65. Yeah. Hit ratio is
55%.
60, 55%. Yeah. So now the page hit ratio is increased. So what we can do is we can choose the optimal page replacement algorithm. So I think so. Hope it is clear for all of you. All of you, optimal page replacement algorithm. Any doubt in this? But there is one disadvantage
no
in this
doubt.
particular. But there is one disadvantage in this particular optimal page replacement algorithm. Can you tell me what will be the disadvantage in this particular optimal page replacement algorithm? One doubt, one disadvantage in this. What is the disadvantage? See here, we are going to predict which is the page that is that will be not used for the longest period of time. Yes or no? Okay, we are CPU is going to predict, or the operating system is going to predict which is the page that is not used for the longest period of time. But always we cannot predict no which page is. See here in this case, I have a reference string. I can just predict that 7 is occurring after so many iterations, or 3 is occurring after so many iterations. But because everything is dynamic in our operating system and CPU is going to choose the pages dynamically, we cannot make sure that okay 7 is going to occur after last, or 7 is, or if you just say here, like say if I have replaced with 2 with some other page, but as meaning saying that 2 will never occur after some time, but after some time the CPU may ask for the page number 2 again. So that is what the one of the disadvantage of optimal page replacement algorithm is. It is very difficult to predict that what will be the next page. See here, see, unfortunately, if you come across with the disadvantage, unfortunately the optimal page replacement is not feasible to implement. Even though the hit ratio is good, it is not able to implement. Why? Because we can't know the future, that is what is the next page, since it is a reference string, since the page whatever the reference string we are looking is, since it is a static one, we can just predict which is the longest which is the page that is occurring for the longest period of time. But in case of dynamic scheduling, we cannot predict. So that is what the one of the drawback of this particular optimal page replacement algorithm. So even in the diagram, if you just see here, you can just see here page fault is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 page fault. And in our whatever we have looked here, okay, so in that case also I can just show here the page fault we had is 9. So that's why I told that the optimal page replacement algorithm can also be cannot be considered. So so what is the solution, sir? So you are saying that first in first out cannot be used because it suffers from Belady's anomaly, and you are saying that optimal page replacement algorithm is fine. It is the hit ratio is increased, but still you are saying that the CPU cannot predict, or the operating system cannot predict like which page the CPU is going to request for. Yes, definitely. But what is the other solution? Let us go for the next type of page replacement algorithm, that is least recently used page replacement algorithm. So what exactly this least recently used page replacement algorithm is all about? See here, if the optimal page replacement algorithm is not feasible, an approximation to the is possible. But the main difference between the optimal page replacement and FIFO is that FIFO algorithm uses the time when the page was brought in, and optimal uses the time when the page is to be used. That is what the difference. FIFO, what we do is first in first out. Which page is we keep track of the time, and which was the whichever the page that was brought first, that was replaced with the requesting page number. But in case of optimal, we are going to check for the time which will be used, longest page number, the time of the page which is the page which is having the longest time. But in case of replace LRU, what we are going to do is replace the page that have not been used for the longest period of time. So it is the opposite of optimal page replacement algorithm. If you just check here in the diagram, if I have the frames, the same string we have taken with the 3 frames, see in this case 701. So already now whenever I want to look for 2, so we have to go back. Okay, we have to go back and check for the which was the page that is not being used for the longest period of time. So let me take this also, and we'll just go through this, because why I'm stretching more on this is it is in the lab exercise you have the 9th program based on this particular page replacement algorithm. Okay, so please have clear your doubts. If you have any doubts in this particular thing, and make sure that you execute the program and prepare. So if you have any doubts in the program also, you can ask me at any point of time. Okay, let me take LRU. I'll just writing that least recently used. Okay, so I'll just mark here. I have some table. Okay, so 1, 2. Okay, 3 frames. Okay, 3 frames I have. So now, so what is the this one? I'll just write 7. Okay, 70701. Okay, so page fault. Okay, I'll just mark it as into page fault is this page fault. Okay, so now I have to replace the page number 2. Now which frame has to be replaced with page number 2? Which one? Tell me. LRU. Which page should we replace?
7.
7. Why we have to replace it with 7?
7 is least used.
Very good. 7 is the least used, means we have to check for the page which has not been used for the longest period of time. There we are checking in the forward direction. Here we have to check in the backward direction. So if you just compare here 7, so it was used 3 iteration in the backward direction, 1 iteration, 0 2 iteration. So which is the longest one? So 7. So now replace it with this one. So I'll say 201 and mark it as page fault. The next one is 0, so it is already there. 201. I'll make it as hit. Okay, I'll make it as hit. Next one is 3. So 3 is not there. So now I have to replace. So if you compare this, whatever the page number that is there in the page table, 201, which is that. So 0 is 0 occurs before 3, so I cannot replace. 1 is there. So which one? Which now in this particular page table, which one I have to replace? 2, 0 or 1? Which one I have to replace with a new page number 3? 1, because it is used in the, because it has not been used for the it has not been used from the last this one. So I'll just say that 203 and make it as page fault. Very good. So next one is 0. It is already there. So 203, make it as hit. Okay, so make it as hit here. So next one is after 0. Now what we have to consider is 4. I think so 4 is the reference string. So whether 4 is there, it is not there. Now I have to replace. So 0 is already, it has occurred previously before 4. 3 is there and 2 is not there. So I'll just say 403 and mark it as page fault. Okay, so next one is 2. So 2 is there? No. But if you look at the page numbers, 4 is occurring before 2 and 0 is occurring before 4 and 3 is the last one. So replace it with 3. So 402, and this is what the page fault. So next one is 3. So 3, if you just look at in the this one, so I have 2 here, previous 4 before previous to 2 and 0 is the last one. So I'll just replace with 0. So 432 and I'll get page fault. Okay. So similarly, if you go for 0, so here what happens in case of 0 here? So if you look at for the 0, so which is the one? 3 is used recently, 2 is also used, and 4 is the not used recently. So what I can do is I can replace that 4 with 0 and make it as 032, and I can just make it as page fault. Okay, next one is 3. So 3 is there. So 032. So it is a page hit. Okay, next one is 2. So 2 is also there. So I'll say 032 and mark it as page hit. So next one is 1. So 1 is not there. So which one I have to replace? 2 is recently the page 2 is there. So 3 is also there. So only 0 is the last one. So I'll replace 0 with 1 and 132 and make it as page fault. So next one is 2. So 2 is already there. So I'll just say 132 and make it as page hit. Okay. So next one is 0. So if you look at 2 is there, 1 is there, 3 is the last one. So I'll just say I'm referring to 0. So 102 I'll take and make it as page fault. Now it is again, I'll come to 1. So 1 is there, 102, and make it as 8. 7 is there. So if you look at the 7, 1 and 0 are recently used, but 2 is not used. So I'll just replace that 2 with the page number 7 and make it as page 4. So 0, so both are there. So I'll write 107, 8. So one more 8 I'll have because 1 0. So now if you compare this 1, 2, 3, 4, okay, 5, 6, 7, 8, 9, okay, 9, 10, 11, okay, 12, 12 page fault, and I think so 8 is what the page hit. 8 is what the page hit. So 1, 2, 3, 4, 5, 6, 7, 8. 8 will be the page fault. But in case of least recently you use the algorithm, you can just find that the hit ratio comparatively to the optimal page replacement algorithm, the hit ratio is reduced, because there the hit ratio was 55%. Now it has been reduced by some amount. So what we can say is the optimal page replacement algorithm is better, but we cannot predict what will be the next page. So this is what he says. So our example leads to 12 page faults. So that is what I showed here also. That is, you can just refer to here 12 page faults I have. So what I can say is 12 page faults better than FIFO, but worse than optimal page. So it is generally good algorithm and it is frequently used. Algorithm is feasible but not easy to implement. Why it is not easy to implement here is because it requires some hardware support, because we need to keep track of which page was not used for which page is not being referenced from previous this one, okay, from the previous time. So that is what one of the major drawback of least recently used. So two implementations are possible in order to overcome from this least recently. What are the two? This one. So LRU can be implemented by using two techniques. One is the counter technique and another one is the stack implementation. So what is this counter technique? So counter implementation is whenever each page table has a counter, okay, so it is having a counter. Every time the page is referenced to this entry, the copy of the counter, copy the counter current clock value into the counter. So what we are doing is whenever we are going to replace the page, so we are going to copy that particular counter value to the page. So whenever, and it is go on incrementing each time. So when a page needs to be changed, look at the counter to find the smallest value. So whichever it is having the smallest value, that page has to be replaced. So search through the page table, search through the page table needed to find the LRU. So this is one which is called as a counter implementation. Another one is what we come across with the LRU is with the stack implementation. What is this stack implementation is? Like say, so keep a stack of page numbers. So we will be having the stack, we'll be using the stack. So in that stack we'll be storing all the page numbers, okay. So that is using the doubly linked list with the head and the tail pointers. So whenever a page is referenced, so whenever that particular page is referenced by the CPU, what we do is move it to the top. So whichever the page that is referenced by the central processing unit, that page is made as the top of the stack. That's all. So most recent usually page is always at the top of the stack, requires 6 pointers to be changed. So because we need to change the if that particular page is residing in the last bottom of the stack, then we have to bring that particular page to the top of the stack. So approximately we require 6 this one. So but each update more expensive. So no search for the replacement, as the LRU page is always at the bottom of the stack. So this is what, so you can just find here the stack implementation. So what is the stack implementation? You can just see here stack before the stack. So whenever like say for example 7 is here, so 7 is in the if you come from the top of the stack, 1 2 3 4. So if you just from the top of the stack, it is the 4th position. The 7 is stored in the 4th position. Currently the CPU has a request for the page number 2 is at the top of the stack. But whenever the CPU requests for the page number 7, now it has to be moved from the 4th position to the top of the stack, so which requires so many movements. So usually this particular thing is implemented with the doubly linked list, okay. So how exactly counter works? Anyone can tell me how exactly the counter is going to work? Birup is not there, I think. So fine, okay, I think so there's no any doubt from your end.